Welcome to Spring LIB.
Hello friends, here it is given. The disk shown in the figure have angular velocity. So disk having the angular velocity 500 rpm in counterclockwise direction. So this could be written as in radian 52.36 radian per second in counterclockwise direction. Radius of the disk is given 2 inch. VD having the length 10 inch. We have to calculate the acceleration of the collar D. Find acceleration of collar D for A part, theta is 90 degree, and B part, theta is 180 degree. Solution for disk A. We are solving for disk A. Angular velocity. Already I have written 52.36. Again I am writing 52.36 radian per second in counterclockwise sense. Angular acceleration of A0 AB is equal to radius of the disk, that is 2 inch. So velocity of B point you can find AB omega into A. AB is 2 inch, omega is 52.36, so it is 104.72 inch per second, and acceleration of B, AB omega square A, 2 inch into 52.36 whole square, so it will be 5483.1 inch per second square. Part A, for theta to be 90 degree. Velocity of V, if you write, it will be 104.72 meter per second in downward direction, and velocity of D is downward direction. If we draw the geometry here again, this is the disk A point, this is B point, this is D point. This angle beta we can find. So from the figure you may see sine of beta will be 2 upon 5, that is 0.4, So beta would be 23.58. Now B and D are parallel. You can see this is the velocity of B. This is the velocity of D. So angular velocity of BD will be 0, since velocity of B is parallel to velocity of D. So angular velocity of BD is 0. Now acceleration of B point already we have calculated. 5483.1 inch per second square towards right. Acceleration of D point is AD in upper direction. Alpha BD is in counterclockwise direction. So acceleration of D with respect to B, you can find BD, alpha BD, direction is beta plus BD omega BD whole square in this direction, but BD omega BD is 0. So acceleration of D in reference to B will be BD is given 10. This is alpha BD. Acceleration of D, you may write acceleration of B substitute the value. AD is in the direction upward. AB is 5483.1 inch per second square towards right. This we have calculated 10 alpha BD at angle beta, and beta we have measured 23.58 degree. Now we will take the components. Components along this direction we are taking positive, so this is 0. 54831.1 plus 10 alpha BD cos of 23.58. So alpha BD you will get negative of 598.26 radian per second square, and if we take this direction to be positive, so component Along this direction you will get AD is equal to 0 minus 10 sine of alpha BD sine of 23.58. If we substitute, sorry, alpha BD calculated above, so AD you will get so acceleration of D will be 199.4 feet. It is to be converted into feet. That will be, I have written it directly. If you like, you may write like this: AD is 2393.0 inch per second square. So later on, it is converted into feet per second square, or you may give the answer in inch per second square. That is your choice. Now, similarly, we have to solve the same problem for angle to be. Calculation is same, only angle is changing. So for theta to be 180 degree, all the concept is the same. I have to draw its geometrical diagram again. This is the point A. This is the line. This is the B point. This is D point. This angle is beta. This is the direction of BD. So from here, you may write velocity of B is 104.72. Already we have calculated in the part A. Only direction has changed. And BD is from the figure sine of beta you may find this is 10, this is 6 inch, so 6 by 10, that is 0.6, so value of beta will be 36.87 degree. Instantaneous center of bar or rod BD at point C. So angular velocity of bar BD will be angular velocity of B upon BD. B is 104.72. BD you have to find. This value is given, so you can take the component of it So tan of cos of beta. On solving it, this value will be, I am writing directly, cos of beta you can find from here. Beta is given. So this value you will get 13.09 radian per second. Now acceleration of v, you may see in the figure, acceleration of v can be written as 5483.1 inch per second square in this direction, AG along this direction, alpha VD is in counterclockwise direction. So acceleration of D with respect to V point can be written as VD alpha VD in the direction this plus VD omega square VD in this direction. So VD is 10. So acceleration of D in reference to V point 10 alpha VD this direction omega VD we have calculated, VD you know, so 10 into 13.09 whole square, this is beta. Ten alpha VD in this direction plus, write this, it will be 1713.5 in this direction. Now you can find acceleration of D, which would be acceleration of V plus acceleration of D. Acceleration of D is AD in this direction. Sorry, I have marked the direction wrong. It is in this direction. Acceleration of AB 5483 inch per second square along this direction plus this value already written above, so 10 alpha VD in this direction. Now we can take the component in right direction positive, so it will be 0 plus 10 alpha VD cos of beta is 36.87 minus, sorry, its component will be positive, so 1713.5 sine of 36.87. So on solving it, alpha BD will be negative of 128.51 radian per second square. Now take the component in this direction positive. This is, remember it, this is the components of acceleration d we are taking. So AD is equal to 5483.1 minus 10 sine alpha BD already we have calculated, plus 1713.5 cos of 36.87. So acceleration of D will be 7625.0 inch per second square, or it would be written as 635 feet per second square in upward direction. So this is the answer in case theta is 180 degree. That's all for this problem.